Store, and let me flip this here so that I can share. You know, I've used, I don't know how many tools, and everyone, right? There we go. The button's in the wrong. So I need to have it sharing for me. If you can, Lee, if you can give me that permission. Right now, I don't have that. There we go. Perfect. Thank you. Okay. And just to confirm, you all should see in a second PowerPoint, correct?
I don't see anything just yet.
I don't see anything yet.
Okay, it's taking a second to refresh. Sometimes it doesn't love the
There
double
it is.
monitors, I think. Now you got it?
Yes.
Perfect. It's still, it like blinks in and out for me. It's really weird. Like the screen goes, both my screens go black and then they come back. But I think we're good. I think we're at a safe spot here. And I'm just going to flip over. You guys can see this then as well, right? When I flip to Management Studio. That looks good. Okay, perfect. One last thing I want to set up, and then we will be off and running, which is my friend and yours, Zoom it. And perfect. Okay. So back to slides. Okay. Fundamentals of Query Store. And I like to understand where you are in terms of your Query Store use. And I know that sometimes that can be a little bit tricky when we're in a remote session. So humor me if y'all don't mind. And if you can, we have a chat, right? I just have to find where it is. In the chat, or if you want to come off mic too, that's fine. I kind of want to know people's experience with Query Store. So if you have it enabled, if you've tried it and had an issue, if you can either talk about that or just put it in the chat. And where is the chat? There it is. That would be awesome. While I'm kind of going through these other slides, because it gives me a little bit of an understanding of where everybody is currently. Tiny bit about me. I'm a consultant at SQLskills, which is we do consulting and we do training. The most important thing on this slide is my email address, Erin@SQLskills.com. We should have plenty of time for you to ask questions today, but if you think of something later or you just don't feel comfortable asking, you can always send me an email, Erin@SQLskills.com. I'm also on Twitter. I have a blog, and within the company, there's a few of us, and I like to mention the team because sometimes I refer to other people during the session, and I want you to know that they're real people, not just made up. So Kimberly and Paul are the owners of SQLskills. They are married to each other. Jonathan, myself, and Tim are consultants. We are married, but not to each other. And we all live in different locations around the US. I'm outside of Cleveland, Ohio. I grew up in Iowa. I went to school in Michigan, so I'm a Midwest girl. But Paul and Kimberly are out in Redmond. Jonathan's in Florida. Tim's in Georgia. So we provide consulting, as I've said. We also provide training. So we have immersion events that are actually running right now. We start IEPTO2 next week, and we present at conferences, the Historical Past Summit. I'm not quite sure how to refer to that right now. Intersection, Bits, and if you want to hear from us on a regular basis, you can sign up to get our newsletter. If you want to understand what we do in terms of training or consulting, just hit our website. I'm not going to go into that in great detail, but again, we do have training going on now, and I'll be doing a full day of Query Store in May. So this is like a snippet of what I can talk about. This is one of my favorite topics. And if you've never tried Pluralsight, which I feel like it's something that everybody has heard about, but every time I do a presentation, there's someone who hasn't, so I still keep mentioning it. It's online training, which we're getting a lot of these days, I know, but you can get it for free if you email Paul@SQLskills.com, and you mention this user group. He'll send you a code that'll give you 30 days free. So I have 2 courses out there on Query Store. There's a ton of other training. We have over 50 courses from SQLskills. So I'll make sure that the scripts from today, along with a PDF of the deck, is made available to you all, probably on your site, maybe, or if you, I guess you can always email me too if you can't find it. And this is the abstract, which I'm not going to read to you, but it's a level set to make sure that you're going to get the session that you're expecting. I'm thinking that you're familiar with SQL Server, but Query Store might be something you've never heard of, or you've tried it and aren't really sure how to use it. So if I come back and I'm going to look through the chat real quick. So someone's played with it a little bit, someone's actively using it. It's enabled, but looking only when there's a problem. Read about it, but haven't used in production. Have to convince my teams to enable it. I hear that a lot. You are not alone. Seeing issue. This is a great example. I'm so glad you put this in here. Senior team members have seen issues with it before, but they can't explain further. And we will talk about what issues they may have seen. And then Lee's got it turned on about 50 databases and has used it a few times. So hopefully, no matter where you fall in that spectrum, you're going to find something new or learn something new in this session today. But the idea is to get you to understand what this feature is about and what it can do. And again, I'm packing a lot into this hour or so that we have because I can talk about it for a lot longer. Okay, so if we think about SQL Server and we think about our role, if you're a DBA, you get pulled in potentially after a problem has occurred. If you're a developer, you typically really aren't hearing about it till after the problem is over. And so if we think about something occurred in the middle of the night or something occurred yesterday and nobody brought it to your attention, what data do we have within SQL Server that we can look at to see what happened yesterday? Right. And we're really limited, right? We have the error log, which is sometimes extremely helpful. But if we're talking about tuning and queries, like not always a lot in there. We've got system health and the default trace, which again, give us information about the server as a whole, the instance as a whole, but about specific query performance, not always a ton of info there. And then there's the last one, which anything you've set up to capture, which includes any third-party tool that you might have. So some of us are lucky enough to have that third-party tool. Some of us don't have that in the budget. I never assume that a customer has it. I assume that I need to work with what's native to SQL Server. Some people set things up, roll their own. But if not, then you're really kind of limited in what you have after the fact. And this is one of the main reasons that Query Store was created. And one of the things that I run into is this hesitation about using it, right? Who should be using it? The short answer is everybody. Everyone should use it. And if you're not an expert in tuning, that's okay. If you're a developer and you're great at the code piece, but you're always thinking about how long does it take for something to run, right? Not really digging into things. Query Store is for you as well. If you're a newer DBA, Query Store is for you. You don't have to be an expert. It was truly designed with anyone in mind that can just go in and start going through the UI to figure out what's going on. Now, if you have done a ton of tuning, you're going to look at Query Store and you're going to go, oh, there's a lot here because there's a ton of data, and you'll start to think of ways that you can leverage it to do more than just find the biggest pain point in your system. So a few basics about Query Store. First of all, is that you get this feature, right, built into SQL Server, no additional install, anything required. You get this regardless of what edition you are running. So standard, enterprise, express, and also in Azure SQL database. And this is a feature that is enabled per database. It is not enabled by default in any version of on-premises. So 2016 is when it was released. 2017, 2019, it is not turned on by default. It is turned on by default in Azure. But again, in Azure SQL database and for managed instance, I believe if you created a new database there. But this is enabled at the database level. And the data that is captured for Query Store gets stored in that user database. It's in internal tables that exist in the primary file group, and they're exposed through system views, which means that if I do a backup and a restore of my database, all that Query Store data goes with you. So if we think about testing, we think about creating a test environment or QA or a dev environment, and we want to compare performance in prod to compare against dev. right? We can take that backup, that most recent backup, restore it, and the old query store data is still going to be there. And then we can start running queries against it and compare, right? Built in, makes testing so much easier. The information that we get in here is a lot. We get at the most basic critical level that you're thinking of, we're getting the text of the query, we are getting the plan, and we get the execution statistics or runtime statistics. I use those two terms interchangeably. They mean the same thing. In 2017 and higher, and in Azure, you also get wait statistics for the query. So query level wait stats, not instance level, right? Not DMOS wait stats, query level wait statistics also. You have the ability to control what queries are captured. And this is very powerful. And this is most valuable in SQL Server 2019. We have 2 options in 2016, 2017. We get 3 in 2019. So you get a lot more fine tuning available there. And then we have the ability to force plan. So there's 2 big punches when it comes to query store. One is this data that it captures and your ability to go back and look at it. And the other is the ability to force a plan, right? Have a query use a particular plan. I will pause for questions, but if you think of them, feel free to drop them in the chat and I'll just check that every so often. So don't feel like you have to wait for a pause. If you've got something, go ahead and drop it in there. So let's talk a little bit about the data that is there. If we think about traditional troubleshooting, typical troubleshooting without query store, you often hit dmexec cached plans, dmexec query plan, dmexec SQL text. If we want to pull the text in the plan, right? This is when we say we're going to query the plan cache, this is kind of usually what we're hitting. And that information exists in what I call this logical plan store within a query store, which is these 3 views that are listed here: query store plan, query store query, and query store query text. So those are the system views that you can access to get basically that same information. For dmexec query stats, which is where we get our performance data, right, for any plan that currently exists in cache, we're going to go over to runtime stats in query store. And something that's really important to understand that I'm going to point out right here, and this is a fundamental difference between the 2. When we think about cache, plan cache, dmexec query stats, that information is sitting in memory and it's what's currently running or been running, right? So when you think about dmexec query stats and you think about the information that it might have for a plan that's in cache, what data, or excuse me, what time frame does that represent in dmexec query stats? And the answer is going to be specific to each plan because those stats are aggregated since that plan got into cache, right? So if I reboot my system every Sunday night, which is not what I'm recommending that you do, but if you do that, right? And we run a query Monday morning at 7 a.m. and that plan goes into cache and we rerun that query over and over again, right? It runs every few minutes easily. That plan can stay in cache for days, for weeks, until the next reboot potentially, right? But then we have others that drop in and out. And so what we see in dmexec query stats is just for however long that plan has been in cache. In runtime stats, in query store, we have windows of time that we configure and we get the execution stats over those windows of time, like across an hour of time or a half hour of time or 10 minutes. So we get this historical data and we can also control the time across which that information is aggregated, which we don't have the ability to do in the plan cache. And then we also, again, get the wait statistics for the query. So this would be similar to what we would pull from dmexec session wait stats. And that exists in query store wait stats. And again, this is in SQL Server 2017 and higher and in Azure SQL database as well. So I'm going to flip right into a demo. I'm a big person in terms of seeing things. And so while I'm doing that, any questions so far? Again, you can drop them into chat, or if it's easier to come off of mute, that's fine too. And if not, I'll just keep talking because
Yeah, it doesn't look like we have anything right now.
Okay. So I've done a little bit of prep here, which is I've restored a copy of Wide World Importers and I'm running some queries in the background. And I've got a whole bunch of windows open that I don't need to have open. So let me just close those to reduce any confusion on my part. My fan is going in my laptop. It's kind of busy. So we're going to come over here to databases and I'll expand this. And then we've got several databases on my instance, but I'm most interested in this Wide World Importers. This is what we're going to work against today. And you'll notice that when I expand that, I have Query Store as a folder here. You will only see that Query Store folder if the database has had or currently has Query Store enabled. If you don't see it, it means that Query Store has never been turned on for that database. And when we expand it, you'll see that we get a set of, these are reports that we can run for this particular database. And depending upon the version of Management Studio you're running, you may see one fewer or a few fewer. I recommend being on the latest SSMS, which I think is 18.8 maybe at this point. I think I'm on 18.7. And note that you do not get the same information in Azure Data Studio. So I know that a lot of folks love Azure Data Studio. I think it's really cool, but this interface doesn't exist over there. So if you want to do anything, you need to come through Management Studio. And I tend to start with, when I'm troubleshooting, with top resource consuming queries. This is where I want to go to see what do I have going on or at a particular point in time. So we'll double click to open up this report. And I'm going to orient you with this window here as it fills in. So over here in the top left over here, these are, it's a bar graph. Obviously, you can see that, right? And this is the performance of the query based on, and this is the default, total duration, which can sometimes be misleading, right? Sometimes you maybe want to look at average duration instead of total, or maybe you want to come in here and look at CPU or execution count. You can do all of that here in this drop down, right? We can select any of these to filter on. But I'm going to stay here with duration for a second. So when I hover over one of these bars, I get a pop-up which tells me what the query is. So I can see the text, and this is a shorter one. For longer ones, it'll drop down to see the rest of it. And then I get information about the object to which it belongs, which this is one of my favorite things. Queries are tied to their objects within Query Store. And I get an understanding about the runtime statistics here. So when I click on a different query, my view to the right and to the bottom changes, right? So on the right, what I am getting over here, you'll see, is this plan summary for my particular query. Let me just make this really nice and large. So across the bottom, we have timestamp, right? And then we've got, this is duration. This is our metric over here on the left. And I have two different plans in play here. The color of the circles doesn't mean anything. It's just how you can differentiate between the plans easily visually. And then when I click on one of those plans, that the plan that's been captured in Query Store, which is the same plan that you would find in the plan cache, that shows up at the bottom. So we can see here I have an index seek with the key lookup, and my other plan is a clustered index scan. So this view, this is where I spend a lot of time. But what I don't love, what I like about this visual is that I can see the difference between my query in terms of performance, right? Which are some really, really bad. In this case, I have 3 that are not so great, and then it kind of drops off from there. So this gives me a good visual for that. But I like to see the words a little bit more. So I have this grid view. And when I switch to the grid view, it allows me to see the object to which it belongs right here, right? And then I also get the text and I get the metrics in a format that's a little bit easier for me to digest. So you have the option to go back and forth. And from here, right, this is one of my favorite columns is this plan count over here, right? So if someone comes in, they're like, okay, this query was running fine, and then it suddenly wasn't running okay, and now it's fine, but I don't know what happened, right? And this is a normal situation, right? Intermittent performance problem. And what frequently happens is that the plan has changed, right? We had what's the good plan in cache, and then we flip to the bad plan, and then something happens and we flip again to the good plan. And if you're just looking in the DMVs, you're not going to see that because we get one plan per query in the plan cache. But Query Store has all of it. So we can go back, and if we have days or weeks worth of data, I can completely change how I'm viewing this, right? So within my configure button up here, I can choose, what's most important for me? What is the resource that I want to filter on? And duration is really common. CPU is really common. IO is another way to go at the problem. Execution count can also be really interesting, right? How many times does a query run in a given time frame? And then how are you going to, I am not John Madden. Some of you might be too young and you don't know who John Madden is. I can look at total. I can look at an average, a min, a max, standard deviation. I tend to go between total and average. Standard deviation is really interested for finding plans that have a lot of variability, finding queries with a lot of variability. And then what is the interval of time? By default, it's going to give me the last hour, but I can come in a little bit deeper there and look at the last 5 minutes, 15, 30. I can widen this out. I can look at the last couple of days, week, or month. How much data I can view is going to depend on how much I'm keeping, and you're going to control that, and I will show you how. I can select a custom date range. I do this a lot. I have a customer that had performance issues at 11 o'clock server time, and this was happening repeatedly. And this is when users were trying to do a certain function and they couldn't. And I'm like, I'm pretty sure that we've got some blocking going on, but let's just go see what's happening in there. And I set that custom range to like 9 o'clock to 3 a.m. And sure enough, I could see, right, this increase in performance right at that 11 o'clock time frame. So you can go in, you can customize this to look at whatever's most important to you. And then again, we have, I'm going to go to one of our entries that has more than one plan, right? We have these different plans which exist. And in this database, I only have a couple, but I have systems that have 10, 20, 30 different plans for a query, and seeing all of those here and being able to flip between them is really useful. And beyond that, when I kind of want to understand these two plans look similar, or let me see what's different without clicking on one and then clicking on the other and clicking on one, right? And you go back and forth. You've probably done that. If I hold down my shift key and I get two plans selected, then I can come up here to this little button up here, which compares the plans. And so then it pops open that view, which allows me to look at them both together. This is a functionality that exists. If I have a saved plan, I can open it and compare it to another one. But it's nice that I have the ability to do that right from Query Store. I don't have to save anything out. I can see them now side by side right here. And so then obviously it's very easy in this scenario to understand the difference. But for more complex plans, this gives you the opportunity to dive in a little bit more. And one thing that I want to make a note of with regard to the plan, if I hover over one of these operators and zoom in, you will see that I don't have any of the runtime stats in here, meaning I don't have any of the actual numbers. This is the plan that was used. This is the plan that you would find in the plan cache. This is what we often refer to as the estimated plan. It's the query plan, right? It is not the query plan with the actual runtime statistics. The overhead of capturing that is extremely high. And so it's prohibitive to try to pull that into Query Store. So this will always be the plan that's used. But remember, right, this is the plan that you love and know. And so if I come in here, that's a dog barking, if you can hear that, sorry. If I come in here and I bring up the properties of the plan over here on the far right, I will zoom in to make this a little bit easier to read. You'll notice that I get compiled values, right? So one of the things I can do when I have plans that have different shapes is I can go into those different plans and start to say, okay, what was the value that was used to compile this? Because maybe I've got a parameter sensitive issue going on here, right? And understanding what those input parameters were helps me figure out why a plan might tend to go to one shape or another.
Hey, Erin,
Yeah.
this is Lisa. We do have a question. I'm sure later you're going to talk about plan forcing, but we have a question from Mikhail about plan forcing. So I guess when we get to that point, just let me know. We can introduce that question.
Sure. That'd be great. So let me see. So I have, that's a quick overview of the UI. Actually, there's one more thing I want to point out. One of the things that I also like to do is when I identify a query that I want to dig into a little bit further, I note the query ID. So this is 8209. And I come over here and I go to my tracked queries report, which is a little misleading, I think, in terms of the name, because I have to put in what the ID is of the query that I want to track, right? So it's not like it's anything stored. So I enter that and I go ahead and push go, and that's going to bring up the history of that query for the last 24 hours, which I just reset this demo, so I don't have a ton here, but I get, again, plan performance over time just for that particular query. So when I want to drill down, this is something that I'll do. And then I may come in here and, change my metrics. Maybe I'm interested in looking at execution count to see how that changes over time or anything else. But these two are the ones that I hop into most frequently. Now, I want to provide the system views, a list of these for reference. I think that coming in here into the UI and working through the UI is a really good place to start if you're new to Query Store. But once you start to get comfortable with it, you may want to dig a little bit deeper and pull some information that you don't easily find in the UI, because the UI you can't configure this. You can't change any part of it, but I can write my own T-SQL. So the Query Store query and Query Store query text, I'm just going to run these two. We'll get a ton of rows back here probably. And I'm going to go ahead and stop some of these that are running. Here's what I want to point out. This query text is at the bottom. And if I start to expand this, you can see that I do get some system queries in here, right? These are statistics updates. There's no way to say don't capture those. I get the queries that belong to different store procedures. And then if you notice here, this pattern looks very similar, right? There's a couple queries here that seem to be repeating. There's this one here, a select stock item ID, and I've got this other one down here, 8371. And the query text looks exactly the same. But what you'll notice, if I scroll over, is that there's a subtle difference in the text in terms of the description for all of these. Excuse me. And I want to point this out because these queries are basically the exact same query, but because the description, the value for the description is slightly different. In this case, it's a 4XL versus a 5XL versus a 6XL. It is a different query within Query Store. So if you're familiar with the way that caching works for queries, in that there's textual matching in effect, and different query texts have different entries, the same is true in Query Store. So what this means, what I want you to start thinking about is, what type of workload do I have? Do I have a mostly parameterized procedure-based workload, or do I have an ad hoc workload where users can type in any value for the predicate, or where spacing and casing aren't followed in a traditional or any type of set way? Because that is going to affect the overhead of Query Store. And so for anyone who said, well, I turned Query Store on and we had a problem and I turned it off, and like, that's all you know, my very first guess there is always that it was an ad hoc workload, because that is going to inflate your plan cache, right? It's going to bloat your plan cache, and it does the same thing to Query Store. So we have all of these unique queries in one system, in one view. And then the ID, this query text ID, gets put into this other view, in this query store query view, where we get a unique query ID. And there's a few things, a few columns that end up making a query ID unique. But if you want to understand the query and the text, you're going to hit these two tables. If you want to understand the plan, you have to know that query ID. And then we take that query ID, which is this column over here, and we get our plan information. And there's a couple cool things here. One is that the engine version and the compatibility level are stored for that plan, which means, again, like testing upgrades, really easy to do. Excuse me. I get my query plan hash, I get the actual plan, and I get a ton of other information about the plan in here. And then again, our execution statistics are plan specific. So then we have this plan ID, which is what gets used in this query store runtime stats. So you can see I've got these different plan IDs, and I've got, let's say all of these are for plan ID 8273. And you'll notice that they're for different intervals. Remember, I said that you get to control the window of time across which your runtime stats are aggregated. Those are these different intervals here. And so when we're looking at our statistics, our runtime stats, they're for a window of time, and they're going to be aggregated. So average duration, average CPU, et cetera. We also get a last min max standard deviation as well. So if you want to hit the underlying tables, these are those. And just as an example, this is a query that I like. Queries that have run in the last 8 hours that have multiple plans. I can come into top resource consuming queries in here, and I can, change my range of time, and I can sort. One of the things I like about the grid view is that I have the ability to sort. So now I can see which queries have the most number of plans, right? But if I wanted to pull that in a different format, I could use a query like this, right? Queries that have executed within the last 8 hours that have more than one plan. So this should give us a smaller number of rows, right? It gives us these two stored procedures, which we've looked at, which have two different plans, as well as two other queries that have executed. Okay. I'm going to take a pause, grab a drink of water, see if I've got any other questions at this moment. Doing okay. All right. Let's hop back to slides for a little bit here. I want to talk about settings. And I'm going to flip back and forth because, again, me being the visual person that I am, I like to show you where these are. So the settings, when we come into the properties of the database and we come down here, we have this query store pane now. And let me make this a little bit bigger. I'm on 2019 here, so it might look a little bit different depending on what version you're on. I want to talk about these settings, and I'm gonna go through them kind of quick. I do have a blog post that goes through all of these, talks about what the defaults are, and talks about what I recommend and why. But I kind of want to highlight a few things real quick in the slides. So I mentioned this already, right? Not enabled on-prem, but it is enabled for Azure SQL Database. And these settings are important because this is going to affect what data gets captured and how long that data stays. And if you're not paying attention, sometimes it can switch to a read-only state, which means all of a sudden it's not capturing data. And I don't want that to happen to you. So this is why I like to go through this, because I don't want it to stop collecting data when you're not expecting that to happen. And as an aside, Query Store is a feature that you turn on and you leave on. I've had people say, well, I just turn it on when there's a problem. And my counter to that is, how do you know when there's going to be a problem, right? When you purchase third-party monitoring tools, if you buy Redgate or SentryOne or SolarWinds, you leave that running all the time. The same is true for Query Store. We want to turn it on and let it go. And these get stored in database query store options. So The first is what's our operation mode? Are we in a read-write state? Are we in a read-only state? Obviously, as I just said, we want to be in a read-write state. We want to be capturing information. The next is query capture mode. So query capture mode in 2016 and 2017 defaults to all, which I do not like. In 2019, it defaults to auto, which is what I recommend for most systems. In 2019, we get custom, which means we get to tweak what Query Store collects. So 2019 and Azure have custom. If you're not on 2019, my recommendation is that you use auto. Max plans per query. This defaults to 200, which I think is a lot, but it's an integer, so you could set it a lot higher. I don't recommend that you change it unless you know that you have a ton of variability in your plans for a set number of queries. I do know of one customer that had to set that higher. Max storage size is a big one. How much space do you want to allocate for Query Store? And you're allocating space within the primary file group. And the default in older versions is 100 megs, which is way too small. In 2019, it is a gig. And in Azure SQL database, it depends on what tier you're in. The question I get a lot is what size should it be? And that's a factor of multiple things. One is that collection mode, right? That collection mode, which I said I didn't like, that captures every single query that executes. We don't need every single query that executes, right? If I asked you, what are your worst performing queries? You would name maybe 5, maybe 20, maybe 50, but you couldn't name all of them, right? So we don't need to capture all of them. Auto filters out those insignificant queries, and insignificant determined by Microsoft. If you want to control what you really filter out, you need that custom capture mode in 2019. But what we're capturing is going to affect how much space we need. And I recommend people start with 4 gigs and then monitor. What's important is that you don't go over 10. And if you're thinking 10 sounds high, I'll tell you that I've had a customer with 100 gigs. Way too much. It negatively impacts the system. In Azure, you cannot set it any higher than 10, which is a suggestion that Microsoft thinks you shouldn't set it any higher than that. And I tend to agree based on everything that I've seen. My cleanup policy is how much data do I want to keep? The default is 30 days. I think that's a really good start. If you like to develop in production, you may want to keep more data so that you can go back a little bit further to look at performance in the past. But I think 30 days is a reasonable place to start. And then my size-based cleanup mode says, okay, as I get to 90% of what I've set for the max storage, do I want cleanup to automatically kick in so that I don't hit the limit? Because if I hit the limit, I go into a read-only state. And I really don't want that. So size-based cleanup mode means if I get within 90% of what I have for the max, I want you to start purging out stuff that's older or insignificant. Ideally, we don't hit this because this is single-threaded and this is really slow. So again, my recommendation is that you set it to like 4 to start, and then you monitor and see what's going on there. Then we have a data flush interval seconds. This defaults to 900, which is 15 minutes, and you don't need to change it. This determines when data gets flushed to disk, and Microsoft recommends not setting it any lower. If you decided to be fun and set it to once a minute, right? That means that every minute it's going to be flushing data to disk, which it's writing it to system tables, which means it's going to treat that like any other activity, right? And that it has to log it, right? It has to use transaction log, has to have IO. So the default of 15 minutes is usually pretty good. This interval length is what you can control in terms of the window of time across which your runtime stats are aggregated. So the default, again, is 60 minutes. If you think you need something that's more granular, maybe you drop it down to 30. There are only specific values available. You can't set it to 17 minutes, right? You can do 60, 30, 15, 10, 5, and 1. And the smaller that interval is, the more space I'm going to need. So this impacts total amount of space. I tend to drop it to 30. That's usually that's usually granular enough for what I'm doing. You may try something smaller, but again, keep in mind that that's going to affect your space. And then the other thing that affects that space is wait stats. So that when you enable Query Store in 2017, 2019 Azure, that is turned on. When you upgrade a database from 2016 to something higher and Query Store is enabled, it's going to turn wait stats on for you. I think that these are useful, but be aware that it's going to require more space to have that. So this custom policy, I want to talk about because those of you that have ad hoc workloads are who benefit from this. And this allows you to set thresholds at which when something exceeds that threshold, then we will capture it. So this again is only 2019 and only Azure SQL database. So the first thing that you have to set is the policy threshold, which is the window of time across which it's going to monitor these things. So you could set that for 24 hours, which I think is a little big. You could set it for an hour, which I think is probably more reasonable and manageable. And that's where I tend to start. And then there are three things that we care about here. The first is the execution count. So let's say that we set that interval to 1 hour, right? That policy to 1 hour. So within an hour, if a query executes more than n times, then we would capture it. So if you know that the query only executes once, right, you can set it to something like 5. And as long as the query doesn't exceed that execution count, it won't be captured unless the total compile time or the total execution time exceeds the thresholds that you've set there. So this is an or scenario. If I set execution count to 5, total compile time to 5 seconds, execution time to 5 seconds. If any one of those, this one or this one or this one, is exceeded, then it will capture the query. So this gives you a ton of ability to control what's captured, but it can be a little tricky to figure out the right values for your system. Doesn't mean you shouldn't use it. I think it's extremely powerful in terms of managing Query Store and performance. I have this as a reference slide. I'm not going to go through it in great detail. It gives you the default values for these different settings. I kind of threw them out there as we were talking. And again, I have a blog post that talks about this and goes through all of them. So you can always refer back to that. And this is in here as a reference as well. Hang on a second. You know what? It's because I haven't been talking as much lately. Honestly, I haven't been presenting as much. It's catching up with me. So the things that we need to think about when we think about the space that we need for Query Store. How long am I going to keep that data, right? What do I have that stale policy threshold set to? What's my interval, right? Default is 60 minutes. I'm probably going to drop it down to 30. Maybe I make it smaller. I need more space. What does my workload look like? The more ad hoc my workload is, the more space I'm going to need in Query Store. That 100 gig Query Store that I mentioned, that was an ad hoc workload, which had hundreds of thousands of unique queries and unique plans in it, because every single execution, last name equals Smith, last name equals Anderson, last name equals Jones, right? Those get stored as 3 separate queries within Query Store. And that adds up when you have queries that run over and over again with different values. And then also, are you capturing wait stats? Those are the things that are going to affect how much space you need. And again, for reference, we have default values for Azure, which are dependent upon tier. In this slide, I say start with 2 gigs in monitor. I've upped that in recent months to 4 gigs. I have a blog post that talks about how you can set up an agent job that will send you an email when it exceeds a certain threshold. You can also use extended events, but then you need another step in there when that event does fire. So I like the agent job. It's just a little bit simpler to implement. So any questions? I'm going to pause here again. Any questions about configuration, the basics of finding queries? Because I'm going to move on to forcing, but I want to make sure everyone is good with this bit. Silence, I think, means, hey, we're good. But again, you can drop them in the chat if you've got questions. Okay. Now, when we're in person, I like to stop here and really get everyone involved, but I won't do that today because it's the end of the day and it's all good. But if we think about this, right? If we have a query that we've identified that we know performs poorly, what do we do to fix it? And if you answered it depends, that's a good answer. The ideal scenario, right? If we can, is we change the code of the schema. We really get in there and understand the root issue and why it's not performing well and fix it by changing the code or by changing the schema. Maybe we add indexes. Maybe we adjust the predicate or the join. Maybe we have to do lots of changes to the tables, right? That one I know really never happens, but ideal world, right? This is what I'd like to see. When we can't really go through a big code change, one of the things that folks tend to do is throw a recompile on there, right? If I have a query that is parameter sensitive, that doesn't just give me 2 different plans, but maybe 4 different plans or 8 or 10 or 15, and different values really have different ideal plans, we throw a recompile on there, and every time it executes, it gets the best plan for those parameters. But the challenge there is that I've just introduced overhead in terms of CPU with my compile time, right? Every time that query runs, it has to go through that. So there's a cost there. I can play this game of what I call manually getting the best plan into cache, which manually doesn't mean like I'm sitting at SSMS doing this. It means I've set up an agent job that for a particular query looks to see if the quote unquote bad plan is in cache. And if so, it removes that bad plan and then it runs the query right away with the good parameters to get the good plan into cache. And that job runs like every 5 minutes, right? That's an ugly workaround, but it works, right? Until we can change the code of the schema. Now, what about updating statistics? I don't love this option because what frequently happens, and this isn't always the case, but what frequently happens is we update stats, which forces a recompile for the query so that the next time we run it, we get a different plan, right? So that kind of disguised the underlying problem. Then we have a plan guide, which I don't know if any of you have ever used a plan guide. It is not my favorite thing in the world. I don't find them to be really intuitive to use, but they're there and they serve their purpose really well. But I think they're a little bit clunky, which is why I love plan forcing within Query Store, because it is ridiculously simple. So we'll come in here and I'm going to fire up my queries and I'm going to have those all run again real quick here. So let's go back to where I was before and run a whole bunch of this in the background. And we'll go back to our top resource consuming queries. And we're going to take a look at, we've got these 2 different queries that have 2 different plans. And let me just double check and see if I'm interested in one versus the other. I'm more interested in this other one. Here we go. While I'm here, I'm going to point out, you see that most of these are circles, but there's a square. A square means a query that was canceled. A triangle means it had an error. Most of the time you're going to see circles, but if you see squares, know that the query was canceled. If you see a triangle, know that it errored out. So in this scenario, let's say that I've taken a look at my 2 different queries here, my 2 different plans, excuse me, right? I have this clustered index scan and I have this index seek with a key lookup. And maybe I think, you know, I really like this index seek with the key lookup plan. Most of the time it's not a lot of rows. I think this is the better plan. So I'm going to force it. So I come in here and I force the plan. And it says, do you want to force it? And I'm like, you bet I do. And so what happens now is that force plan has a check mark, so that I know that's the one that's forced. And that is the one that will now be used going forward. No matter whether I free procedure cache, whether I recompile, that's the plan that's going to be used. Now, there was a question from Mikhail about what's the situation where a forced plan was not used and the forced plan failure count was 0. I believe the scenario you're describing is when there's a plan that is what's called morally equivalent, which means the plan has the exact same shape as the forced plan, and that is the plan that is used. And technically, that's not a failure. So if you looked at the two plans together, they would have the same shape, but you might notice some differences in the estimates, for example, or the number of threads potentially with a parallel plan. But that's why that can occur, where it doesn't show that it's failed and it's not using the forced plan, but performance is still or it's the plan you might expect. It's because they're quote unquote morally equivalent. So now that I force this plan, this is what will continue to be used. So if I refresh this window, I'm just going to continue getting the green dot. That's the plan that it's going to continue to use until I unforce it, which is also really easy to do. I can just come in here and I can unforce it, and that will take that plan away from that query of being forced. Now, here's the thing. My recommendation, one of these things, let me make sure that I have this in here. You can do this with T-SQL, but you don't have to. I like doing it with T-SQL, and I don't have the ability, by the way, here to like script out that forcing. I like doing it with T-SQL because then I can put it in change control, because I know we all use change control, right? Because then I know when that plan was forced. So Anil says, forcing a plan leads to a failed query execution. No, I don't think that's what I said. Maybe you could rephrase the question. When I force a plan, then that is the plan that will be used by the query going forward. So right now, if I came in here and I just did a whole new query, I don't want to do a new virtual machine. That would be a disaster. If I came in here and I did free proc cache, which you never want to do in production, right? That would drop all of the plans from cache. But if I come back in here and I refresh this, it's still going to continue to use that same plan. There is a scenario where it cannot use my forced plans. There's different reasons for that. I honestly actually don't have time to go into that, but an example is if we had a plan that was using a particular index, and in this case, I think we're using a non-clustered index, right? So this is a non-clustered index called FKey sales customer transactions customer ID. If I force this plan, and then for some reason somebody comes in and drops that index, then it can't force this plan anymore because the index that it needs doesn't exist, right? So one of the important things about plan forcing is understanding that it's a temporary solution, right? Plan forcing isn't my long-term fix. It is, I'm going to use this as a stopgap until I have a better long-term solution, until I can change my code or my schema, right? Or put something better in place. So that's manual forcing, okay? That's available to everybody, every edition. Nothing special. It is special, sorry, but you don't need anything extra in order to do manual forcing. We also have the ability to do something called automatic plan correction, which is where SQL Server does the forcing for you. So I want to step through and show you that. I'm going to turn on Query Store with settings that we care about. And these are not settings for production. These are settings just for a demo. And I'm going to make sure that we clear out any data that sits in there which is also really for demos. If I run this against production, then all of the data that's sitting in Query Store is gone. It's basically like truncating all the tables. So it's good for demos, not for prod. We're going to create this store procedure that we're going to use for our test, which just has a couple queries in it. And actually, you know what? This is not what I want to show you. I want to show you something else. This is what I want to show you. My bad. I was prepping for the wrong demo. So let me step through what we're going to do here. Same thing that we did before. I'm restoring a copy of this database. I'm going to turn Query Store on, and I will clear out everything that's in Query Store. And then once we've done that, we're going to take a quick look at our automatic tuning options. So automatic plan correction is a feature that was introduced in SQL Server 2017, and it's also an Azure SQL database, and it is Enterprise Edition only. So manual forcing, any addition, all versions, go for it. Automatic plan correction is going to be Enterprise only. So I need to make sure I'm in the context of my wide world importers database. And you can see that this force last good plan, which is automatic plan correction or APC, this is actually off. So we need to turn it on, which we will do. And then I'm going to create a scenario with a parameter sensitive query. And we're going to do that based on these customer IDs. So let me just show you this distribution so you can understand what you're going to see. I have customer ID 1 and 401. They each have about 500,000 rows. Every other customer ID has 3,500 rows or fewer. So definite skew here in terms of my customer ID. I'm going to push the distinct values for customer ID into a table, which I'll then use for queries, but I'm going to get rid of 1 and 401. So I'm basically getting rid of those kind of outliers so that I can have consistent performance so we can see that outlier performance better. And then we're going to create this procedure which pulls back the customer ID and does an aggregate on amount excluding tax. And then it groups by the customer ID. So this will really drive a plan one way for those customer IDs with 3,500 or less, and it's going to drive a different plan for 1 and 401. And then I've already got this event session in place, so I'll just go ahead and start it. Oh, it's already been started, even better. So now let's run my workload here. So we're going to go into automatic plan correction, and we are going to start this up. And then we'll take a look at what we get within Query Store. So let's just make sure that this starts running. It does. And then within my wide world importers B database, very important I'm in the right database. If we look at my top resource consuming queries, and again, I'll flip to the grid view because we can see exactly what this query is. Right? We can see that this is running, and it's running a lot, right? 1,300 executions so far. If I refresh this, we're up to 1,800. And if you look at the plan, this is the plan for the low number of customer IDs, 3,500 or less, right? We see that we get this index seek and this key lookup, which feeds into a nested loop with a stream aggregate out to our select. Great. Now, what we're going to do is we're going to create a regression. We will run that stored procedure. I'm going to force a recompile, and we'll run it with a value of either 1 or 401, which is not unique, right? And this is going to force a change in the plan. And what's going to happen, if everything works the way that it should, is that SQL Server is going to detect that the plan has changed and that it has regressed. And it's going to go and automatically force the last good plan. So this will take a second here. I need to see this run to make sure that everything's good. And let me see what happens if I refresh in here. The suspense is killing me. What will happen this time in the demo? And because I'm impatient, I want to close it, but I'm going to let it sit. And then I say, forget it. And we'll try it again. My other one is still running here. So let me just reduce contention for a second and stop that and see if I can get that to go. There we go. So I've run the script to create the regression. And if I refresh, you can see that it's gone to a second plan. And this plan here is a clustered index scan. And because I messed things up and I canceled this, I basically made the whole thing fail. That's okay, because we will do this. We will rerun our original script, basically reset this. And that's going. Excellent. And I'm going to change this window just a little bit. Let's go instead of the last hour, let's go last 30 minutes. Starts to look a little bit more fun. And now let's try and create that regression again. So what I want to happen in this scenario is that when that regression occurs and when it switches to the plan that has the clustered index scan, it recognizes that that is a worse plan, that it has regressed. And so it will go and it will force the other one for us automatically. We don't have to do anything. What it's hanging out for, I have no idea. And I don't know if I have who is active installed to investigate, but let's just check. I do. I don't have any blocking. I just have multiple threads running. There we go. So now it's running. Let me come back here and let me refresh. Totally failed. So total demo fail. Totally cool. No problem. I'm going to move on from that. What should have happened is it should have gone into a state where it checked plan ID 25 and made that, plan ID 7 and made that my plan. And you know what? I'm really annoyed. Hang on. I'm really annoyed that that's not working because it's a really fun demo. So humor me, friends. Let me query. Let me clear this out. This will all go away. Perfect. Fire it up. Refresh here. There's my query. There's my plan, my index seq with my key lookup. We get 1,000 or so executions in here. Great. Regress. There we go. So now you can see that it has forced plan ID 3, right? We didn't do that. It did that on its own. And I have this other plan ID 7. So here's an interesting thing is it's detecting a regression. And if you look at this, you're like, hang on a second. The green dot is higher on the graph than the purple dot. I don't understand what you mean by a regression. It's a fair question. By default in this view, we're looking at duration. We're looking at total duration. The threshold or what it looks at, the resource that it looks at to determine if there's a regression is CPU, and it's looking at average CPU. So if I change this to be CPU time and average, you'll notice that this view makes a lot more sense, right? Our average CPU previously was down in the 30 range. When that clustered index scan plan came in, it jumped up to 160. So SQL Server noticed that, and it came back and automatically forced that. And we have information about this in extended events, which I did set up, but also in DMDB tuning recommendations. So in here, we can see average CPU time changed from 16 to 159. It says it's in a verifying state, right? It tells us when that started, and it hasn't reverted yet. And so it will keep that plan as the forced plan until there is a schema change or until there's a recompile due to an update, or until there's an update to statistics. So schema change, update to stats, that will automatically unforce, or if forcing fails for some reason. So again, if somebody takes an index away or something else occurs and forcing fails, then it automatically unforces. It's important to know that if you manually force a plan, it will never be automatically unforced, right? Only plans that get forced automatically will be automatically unforced. And Lee says, is this something that I recommend turning on? I do. I have it turned on for one of my customers. And I then go in and I look at this information on a regular basis to see what queries is it continually forcing and unforcing plans for, because this is a circular process that goes round and round. And those are queries that I think, okay, these are problematic. I need to do something about them. So this sometimes saves me from having to get involved in an issue because SQL Server addresses it for me automatically. Note that if I come in here and I create an index, so if we look at this, you can see this has a missing index recommendation, right? A non-clustered index truly is the solution for us in this scenario. And so if I come in here and I create that non-clustered index, this is a schema change. So if I come back over here and I refresh, that is unforced, right? And I have a new plan ID here, plan ID 14. And plan ID 3 is no longer a forced plan. And if I click on 14 and I look at this, it is doing an index seek against that index that we just created. Okay, so schema change caused it to automatically unforce, and then it gets a new plan. And in this case, it's a new plan because we have a new index for it to use. I'm going to flip back to the slides, but if you have other questions about that, put them in there. Let me know. So this is a screenshot from somebody who attended one of my classes, and they sent it to me. And they had this one query, 1464, right? And it ran well most of the time. If you look, and you can see there's 10, 15 different plans here. It ran well most of the time, but they had this one outlier. And when this came along, right, CPU just spiked on the server. Now, what I would have done is I would have forced one of these other plans that was consistently pretty good. But what they did was they added a recompile to that query, which meant, by the way, that it has a new query text. So it's now 3320. And now you can see there's a whole bunch more in terms of plans, right? Before we maybe had 10, now we have at least 20 or 30. So this was interesting to me. You could have forced it. Long-term would have been, I think, rewriting the query, potentially branching it out into a couple different queries based upon different input parameters. This is where plan forcing is a temporary solution that I would use as a stopgap until I could figure out how to address that longer term. So in general, not just for plan forcing, but for query store, my recommendations are you run the latest build of whatever your release is. So for 2019, I think it's, is it CU9? For 2017, it's at least CU22. And for 2016 Service Pack 2, I can't even pretend to remember. I want to say 15. Oh, thank you, Frederick. CU10 just came out for 2019. The reason is because as there have been some challenges discovered with Query Store for particular workloads, they have backported those fixes into 2016 and 2017. So that's why I want you, and there's a couple really important things that were in one of the most recent CU. So I'd really like to see folks on their latest CU. Make sure you configure those configuration options appropriately. Query capture mode, max storage size, two very important ones. Trace flag 7752 and 7745. I'm going to recommend them. I'm going to refer you to a blog post that I have that talks more about what they do and why I recommend enabling them. Monitor your forced plans. Let me hop back over here to Query Store for a second, and let me manually force one of these plans. Sure. You have a report in here called Queries with Forced Plans. It is not set it and forget it. It is set it and let's pay attention to what's going on. This tells me what queries I have with forced plans in my system. I think it's a really important option, report to use. So monitor those on a regular basis and understand the impact of your ad hoc workloads. So this is what I need you to think about before you enable Query Store if you haven't already. I need you to understand your workload. So let's make sure we're on the same page about what we mean. So a procedure-based or parameterized workload means that the statement that you see is the same every time it's executed, right? Rather than last name equals Stellato, it's last name equals at last name, right? It's parameterized. Either that's the way that your queries come in, or because you've got stored procedures in there. This means that the first time that query executes, it goes through compilation optimization, the plan gets put into cache, and every subsequent execution, regardless of what that input value is, reuses that same plan. There's good and bad to this, right? But and that's a whole nother conversation. But understand that that means we have typically good plan cache use. Example, right? We declare a variable, or excuse me, we declare a parameter called color name. We set it to some value. We pass it into the query below. On the right, we declare a customer ID as an integer. We set customer ID to a value. We pass it into the select query below. These are what I mean by procedural or parameterized queries. An ad hoc query has a different text for each individual execution. So it uses literal values, and that means because of textual matching, every execution is a different entry in the plan cache and in Query Store. So for example, right, my query on the left where color name equals, instead of an at color name, it's blue or purple or yellow or red or green or violet or pink, right? Whatever it is, turquoise. And every single one of those different colors is a different entry. My query on the right, customer ID, 3284 is one. 3285 would be a different query, different entry, 3286. And when you do the colors, you're like, well, there's not that many colors. But when you do a customer ID or when you do a GUID, right, all of a sudden, I have hundreds of thousands of what look like different queries in my plan cache or in Query Store, but they're really exactly the same. They just have different text. So this is what you have to understand before you turn on Query Store. And if you're not sure, I've got a couple blog posts here to help you figure that out. Because if you have an ad hoc workload, if you use nhibernate or link to SQL or entity framework, you have an ad hoc workload. And in that case, you need to be on SQL Server 2019 latest CU and use that custom capture mode. Because otherwise, you're going to end up with a Query Store that's 10 gigs or 20 gigs or 100 gigs in size. And that's where you experience performance problems, which look like they're from Query Store, but in reality, those performance problems are because of your workload, right? This is just kind of how they're manifesting. You already have issues with high CPU, with plan cache bloat. And so now when we turn Query Store on, those get exacerbated. So your takeaways beyond understanding what kind of workload you have before you turn on Query Store are that Query Store is invaluable for troubleshooting query performance, that it is an incredibly helpful tool in terms of plan forcing, whether you do that manually or automatically, that beyond that, you can go in there and you have all of this data that you can use to start to proactively look at your workload, right? You ever want to know all those queries that developers have written that use no lock or that force order or have a particular query hint?
All of that query text is in Query Store. You can go find that. You can understand your weights, your query weights, your plan weights in 2017 and higher. And it's a great resource for testing, right? A pre and a post scenario, 2016 to 2019, or application upgrade. All that data is right there. New functionality is going to continue to use Query Store. This is not a feature that is kind of half baked and is going to be left, right? This is full on. Development continues. There's more to come. Trust me on that one. So this is something that I really recommend that folks start to use. You just need to be on 2016 or higher. So I've got a bunch of blog posts, and I'm going to actually, let me do this really quick. Because I want you to see this one. Hang on. Here we go. This blog post, Query Store Performance Overhead. For those of you who have had trouble getting buy-in, this is the blog post that you want to read. I wrote an original post over 2 years ago, back in 2018, and then I updated it with most recent things in November of 2020. So this talks about the important things that you need to know. And then it also has a link, I think, to best practices. So that's a whole different blog post. That is this one. And this links to the settings blog post that I mentioned. This links to the trace flags blog post that I mentioned, to the performance one over there, and information about the different fixes and the ad hoc. So these two are really great places to start. If you watch this and you're like, oh my gosh, there's a lot, these two will help kind of pick up where we left off and get you on the right path. So let's see, resources here, courses on Pluralsight, and that's it. I might have gone a little long, but I think most of you hung in there with me, so thank you. So any questions?
We really appreciate it. Any last questions from anyone?
I do have a question.
Mm-hmm.
So we have a settings on a SQL Server instance optimized for ad hoc workloads that affecting query cache behavior. Is it affecting our query store?
Nope.
So it's still bloated. Okay.
So, well, yeah, your query store will still be bloated because you have an ad hoc workload. That's why you need 2019 and the custom capture mode. Yes.
Okay, thank you.
Mm-hmm.
It was great presentation. Thank you very much.
Oh, thank you. Thanks for being here. If you think of questions later on, again, feel free to email me. Just mention this user group, and I'm happy to try to help out where I can. And again, I'll send the deck and the scripts over to Lee. So if y'all want to play with them, you can.
And just one little question.
Mm-hmm.
Sometimes is when the developers asking the question DBA, they mention, hey, my stored procedure is running slow.
Mm-hmm.
They don't mention like query ID. So you have to like find it. You have to find it like stored procedure. Stored procedure could be like hundreds queries, and you have to find which one is.
Right. So I have a query for that. So this will help you find. Oh, I might not have this in the context of the right database. Hang on. Actually, I have a blog post about that as well. Hang on. Here it is. This will give you the code. So this is finding the slowest query in a store procedure. So this is all the demo code. That's a lot of setup. That's a lot of setup. But this is the same stuff that I have over here, right? Which tells me here are the particular queries in the store procedure, and it breaks down the duration information. So I agree with you. I think what you want to say, or I think what you're getting at, is that there's no easy way in Query Store to see all of the all of the queries which belong to a particular procedure, and then see which one is running the slowest. True, there's no report that gives you that, but this data is here in Query Store, and here is the T-SQL that you can use to pull that out. In addition, sorry, if you guys got to go, I totally understand. QDS GitHub. Here it is. This GitHub repo. It's called QDS Toolbox. This is from a company called Channel Advisor. And this is pretty cool. So those of you that are ready to go to next level, I'm going to tell you to check this out, because this helps you find query variation, query weights, top queries, and it does information that or pulls information based upon the procedure. And if you, Lee, this might be useful for you. If you have Query Store enabled on multiple databases on an instance, when overall performance is slow, you don't know what database to look at. So they have some queries in here that look across all of the query stores for all the databases on an instance and help pull out what's most expensive.
Yeah,
Yeah, that
is
sounds
cool.
nice.
Yeah. Ken, I know I'm not John Madden. I tried. Some days I can draw really well, not today. All right. Last call. Everybody good? Everyone's like, yeah, we're ready to go chill.
Yeah, I think we're at the end of our time, and we definitely appreciate your time and,
Okay.
and volunteering, Erin, and showing us how to get started with Query Store and why we should be using it. So we definitely appreciate it. Thank you very much.
No problem. Thank you all for being here again. I don't know if you have any closing remarks or if I should just say bye.
No, I think we're done. I don't have any closing remarks. So I appreciate your time, and thanks everybody for joining. We'll see you in 2 weeks. Thank you.
Thanks. I'll take care.
Thank you.